Let's balance equations for redox reactions in acidic conditions. First, we separate the equation into oxidation and reduction half reactions. Then we balance the atoms in both half reactions. First, balance all elements except for hydrogen and oxygen. Second, balance the oxygen by adding water to the side that needs more oxygen. Thirdly, we'll have to balance the hydrogens that we've added by adding water. So we add hydrogen ions to the side that needs more hydrogen. The third step is to balance the charge by adding electrons to the more positive side of the reaction. Now in Gen Chem 1, we didn't have to worry about adding electrons. We only balanced equations for the number of atoms on each side. But in redox reactions, the reactions must be balanced in terms of number of atoms and also the charge. If necessary, we multiply the half reactions so that the number of electrons in both equations is equal. And the last step is we add both half reactions to cancel all electrons. We've been given an equation which we need to balance in acidic conditions. The first step is to split this equation into two half reactions. We can see that iron is being oxidized to iron 3. We can tell it's being oxidized because the oxidation number is going up. When the oxidation number goes up, the substance is being oxidized. Remember that when we are talking about substances being oxidized or reduced, we are only talking about reactants. This must mean that the permanganate ion is being reduced. In order to assure ourselves that the permanganate ion is being reduced, we can determine the oxidation number of manganese in the permanganate ion. Let's say we do not know what the manganese oxidation number is. We'll call it X. To that, we know that oxygen, the oxidation number of oxygen is -2, and we have 4 of them. So that's -8 total. So X minus 8, we set that equal to -1 because that's the charge on the species. And X equals +5. So the oxidation number on manganese is +5. We can see that manganese is getting reduced to +2. So the first step is splitting into two half reactions. We have the oxidation half reaction and the reduction half reaction. The next step is to balance the number of atoms. Iron, we're all set with iron, 1 iron ion, 1 iron ion. 1 manganese, 1 manganese. However, we have 4 oxygens, so we have to add 4 water molecules to get the 4 oxygens. But you can see in doing so, we've added 8 hydrogens. So we must add 8 hydrogen ions to the reactant side to balance it out, to balance out the 8 hydrogens on the product side. Step 3 is balance the charge. So we have 2+ on the reactant side for the iron, 3+ on the product side. If we add an electron to the product side, the net charge is 2+, which balances out with a net charge of 2+ on the reactant side. We must add 5 electrons. The reason is, you can see in the last reaction of step 2 that we have a 2+, a 2+ on the manganese, and we have 8 pluses on hydrogen and 1-. The net charge on the reactant side is 7+, and on the product side is 2+. If we add 5 electrons, now the net charge on the reactant side is 2+, and the net charge on the product side is 2+. The fourth step is to balance the number of electrons. You can see in step 3 we had 1 electron on the oxidation half reaction, 5 electrons on the reduction half reaction. So we must balance the number of electrons by multiplying the oxidation half reaction by 5. And when we do that, we have 5 electrons being transferred to the permanganate ion. We also know the acronym oil rig. Oxidation is loss. So you can see that iron 2 has lost its electron. That's the reason it's way over here. And reduction is gain of electrons. Oil rig, reduction is gain. And you can see that the permanganate ion has gained 5 electrons. That's the reason they are on the reactant side. So now we've balanced the two equations in terms of number of electrons. So now it's okay to add the two equations that result from step 4. And you can see that the 5 electrons on the product side in the oxidation will cancel with the 5 electrons on the reactant side of the reduction, leaving us with the resulting equation. And now here's a problem for you to do. And here's the answer so that you can check your work.